All right, we're going to start at number 13 in this video and see how far we can get. But number 13 is just cosine pi over 3. With these, most of these, if I can, I'm going to just try and refer to the unit circle and answer as many questions as I can through that. So here it is, a completed unit circle. So I'm trying to look at cosine of pi over 3. So if you remember the idea behind this, I can draw maybe red. If I drew a triangle that encompassed this angle pi over 3, here's the angle pi over 3. And when we do that, we know that the hypotenuse in the unit circle is 1 by definition. What else we know about this? We have the opposing angle, or the complementary angle, I think it's called. Anyways, the other angle of this triangle is 30 degrees. And when we have a 30, 60, 90, like 30 and 60 and 90, so we have 1/2 on the short side, and we have square root 3 over 2 on the longer side, and then of course 1 on the longest side of the hypotenuse. So when we're being asked for the, in this case, cosine would be the adjacent side right here, the adjacent side over hypotenuse. Well, that's really asking for just the adjacent side, because the hypotenuse is 1, and when you say adjacent over 1, it's just the adjacent side. So when we go to plot this coordinate here, we went over x and we went up y. So we have over 1/2, because see, our triangles, although this triangle and this triangle are similar, they're just oriented a little bit differently from each other. And so as we look at this, we're going to notice that we want the cosine, we really just want the x value. We just want to know that value of, of the coordinate xy. So when we go back, cosine pi over 3 is just 1/2, because it's the x coordinate, or the x distance in the xy coordinate. And then we box it in, of course. 14, here we go. 14 sine of 90 degrees. Let's go back. I'll erase this, because if you really want it, you can go and rewatch the video. So there's my unit circle, sine of 90 degrees. Well, here's 90 degrees right at the top, right? There's 90. So sine, remember, if I really just quickly did, and maybe not even up here, do it up here. Let's go back to this triangle. When we do sine of this angle theta, that's the opposite over hypotenuse, which is equal to 1. So if I'm asking for the sine of an angle, I'm really asking for the y coordinate of the angle to get to the xy position. So in this case, green for the answer, 90 degrees right here, we're looking for the vertical distance of that angle. So the answer is 1. So we go back here, answer 1. All right, 14, done, check. Now 15, we're going to move up a little bit. Okay, anyways, tangent of pi over 4. Well, let's go back to the unit circle. Pi over 4. Erasing. There we go. Pi over 4 is just 45 degrees. That's right here. So we need to know the tangent of pi over 4. So if I drop this down and make our triangle, there's 45. Tangent is asking for the y value over the x, y divided by x. So tangent of the angle is just the y over the x. And the reason is we've got tangent is opposite over adjacent. In this case, opposite would be the y position, and adjacent is the x. So it's pretty simple. We just take the y position, square root 2 over 2, and we divide it by the x position, which also happens to be the same number. So when you take a number and divide it by itself, the value just becomes 1. Just like number 14, answer is 1. Now we got to go back up to the top. We're going to start diving a little bit more into the unit circle. We're going to go beyond quadrant 1. Dun, dun, dun. What's going to happen? Well, not a whole lot's going to change, let's be honest. When you look at 5 pi over 4, so now we're looking for tangent of 5 pi over 4. So let's see, 1 pi over 4 is here, 2 pi over 4, or pi over 2, and there's 3, there's 4 pi over 4, there's 5 right there. So I'm going to erase all my other ones to get there. So we're looking for what? Tangent? Yeah, tangent of 5 pi over 4. Well, we just did tangent of pi over 4 here, and we said that we took root 2 over 2 divided by root 2 over 2, and we got 1. Well, let's look down here. I'm going to change my green to a little bit different, a more different green. Anyways, when I do that, I'm going to see that I have the negative square root of 2 over 2 over negative square root of 2 over 2. And when I have a negative number divided by its negative self, I'm still at 1. So let's go back. We're on a roll here. Answer, believe it or not, again, is 1. Okay, sine of 270 degrees. And they're making this too easy on us. 270 degrees is in, well, it's not really in a quadrant, it's actually the divider between quadrants 3 and 4. So there's 270. Get that better green out there. There's 270 degrees. We want to know the sine value. So remember when we talked about that in the other problems, sine goes with the y value of our position. Our position's right here at 0, -1. So the y value is -1. We just say sine 270 is -1. And we move on. All right. It's looking good. 7.5 minutes. We're already 17 problems. Okay. Number 18, we're looking at cosine of negative 7 pi over 6. Let me re-emphasize that. That's negative 7 pi over 6. What that means is we got to be careful what direction we go. So here's negative direction. There's negative 6 pi over 6, right? Or just negative pi. We go one more pi over 6 to get to negative 7 pi over 6s. Well, really all that's doing is causing us to look at this triangle right here. What is that reference angle? Well, it's pi over 6. So when we're looking at cosine of this angle, we're looking for the x position, because again, unit circle is 1. And what we notice is x over 1. Well, here's my x coordinate. So my answer is just the negative, there we go, negative square root 3 over 2. Because that was our x value of that position. Moving on, 19, look at this. We're rolling 315 degrees. Well, I can tell you anything that ends in a 5 like that, chances are it's going to have a reference angle of 45, right? Because when we do this, 315, well, there's 90, 180, 270 plus 45. 70 plus 45, that's 315. Check cosine 315. So now we're down here. Reference angle here is 45, which means my x and my y are going to be the exact same values, but different, same magnitude. I should be careful with that. Same magnitude, meaning the same numbers, just different values, because one's positive, one's negative. So we're looking for the cosine, so we gotta look at cosine. Cosine goes with x, and to get to the fourth quadrant, we used a positive x value and then a negative y. So in this case, our answer is the positive answer, root 2 over 2. Yeah? Okay. 19. Question 20, 11 pi over 3. Well, that's a little different because all of a sudden our comfort zone of, oh, just find the answer inside of our unit circle. All these answers, right? Just keep looking, and we run out of spots, right? We get 5 pi over 3, and then we stop, like that's the highest we have. So what do? We put the sheet away and we go to bed, right? Because it's 10:30 at night here. No, what we're going to do is finish this one problem and then probably pause the video because it's 10 minutes long. So, real easy. We're going to look back, make sure we're doing this. 11 pi over 3. Very simple, you guys. You're going to take, I'll do blue. You're going to draw blue. You're going to go 3 pi over 3 to get pi. 6, so 3, then 6 pi over 3, which is 2 pi. We got 3, 6, 9. 9 puts us the second time around here. 10, 11 pi over 3. So that is actually right here. I need to erase that extra stint there. That 11 pi over 3 is in the fourth quadrant, and reference angle is pi over 3 in the fourth quadrant. So as we look at that, we're saying we need to find, this is my reference angle, and question 20, I believe, yes, is looking for sine. So sine of 11 pi over 3 is the y value of just 5 pi over 3. And if you look at what the y value is, it's negative square root 3 over 2. So negative square root 3. And just like that, you've got another answer. That's plenty here. That's 12 minutes. I'm going to stop there and continue in the next video.